Welcome to Lesson 5.2 Preparing Chart Datasets. Overview. Va dad a da dad di a dia dad is ta kofis practice. You'll master these techniques quickly. Everything in Chart fine-tuning lives or dies by the quality of your training data. Before we touch a single training parameter, we need to understand how to design, create, and validate the conversations that will shape your model's personality and behavior. That's exactly what this lesson covers, and by the end, you'll have a complete production-ready chart dataset of 200 to 500 examples built from scratch. Learning objective. Here's what you'll walk away with. You'll know how to design effective single-turn and multi-turn conversations, write system prompts that actually control model behavior, generate synthetic training data at scale, validate your dataset for quality issues before they become training problems, and format everything correctly for onslaught. Think of this lesson as building the raw material that all your future fine-tuning runs will depend on. Chat data requirements. How much data do you actually need? Here's the honest answer. 50 to 100 examples gets you a working prototype, useful for testing, not for production. 2 to 300 high-quality examples is a sweet spot for standard chart fine-tuning, and that's our target today. 500 to 1,000 pushes you into production-grade territory, and beyond 1,000 you're training complex, nuanced behaviors. The recommendation: start with 200 to 300 examples, nail the quality, and scale from there. There is a principle worth burning into memory before you write a single training example. 100 perfect examples will outperform 500 mediocre ones every time. The model learns patterns. If your patterns are inconsistent, contradictory, or vague, that's exactly what gets baked in. High-quality data means diverse scenarios, a consistent personality throughout, natural conversation flow, clear and helpful responses, zero contradictions, and examples that actually represent the situations your model will face in the real world. Designing your chart dataset. Before writing a single training example, you need to answer 4 design questions. These aren't formalities. The answers directly shape every conversation you create. What is the assistant's role? What personality should it have? What tasks will it perform? And what constraints should it always respect? Getting these wrong means your dataset pulls in multiple directions, and a confused dataset produces a confused model. The role defines the assistant's domain and identity. Tech support for Windows issues, creative writing coach, Python coding assistant, fitness and nutrition advisor. Each of these implies a completely different vocabulary, a different depth of expertise, and a different kind of user. Pick one and commit. Your entire dataset will be built around it. Personality is how the assistant sounds, not just what it says. Professional and concise reads very differently from friendly and encouraging or casual and funny. Patient and educational implies a slower pace, more explanation, more reassurance. Whatever you choose, every single example in your dataset needs to reflect that same voice, because inconsistency here is one of the most common reasons fine-tuned models feel off. Task types define what the model actually does. Answer questions about topic X. Provide step-by-step instructions. Generate creative content. Debug code. Your dataset should cover the full range of tasks your model will encounter, not just the easy ones. If you only train on simple questions and answers, that's all your model will handle gracefully. Constraints are the guardrails. Always output JSON format. Keep responses under 100 words. Never provide medical advice. Cite sources when possible. These need to appear consistently in your system prompt and be reinforced through your training examples. If a constraint matters, Show the model following it across many different scenarios, not just once. With those 4 questions answered, you can write your system prompt. The system prompt is the single most powerful lever you have over model behavior. It sets the context for every conversation in your dataset. Here are 3 concrete examples worth studying. The tech support system prompt establishes the assistant as a helpful Windows technical support specialist. It defines the tone, patient, clear, structured, and sets the expectation that responses walk users through troubleshooting step by step. Notice it also includes a constraint. When a problem is beyond scope, the assistant should direct users to official support channels. That boundary matters because without it, the model will attempt to solve everything, including things it shouldn't. The creative writing coach prompt takes a completely different register: enthusiastic, encouraging, collaborative. It positions the assistant as a brainstorming partner rather than an authority, which changes the entire shape of the responses you'll write. Where the tech support prompt drives toward definitive solutions, this one drives toward questions, options, and exploration. The personality difference is intentional and needs to be reflected in every example you create for this role. The Python tutor prompt lands somewhere between the two, patient and educational, focused on clarity and correct practice. The key word here is patient. That one word implies the assistant should never make the learner feel slow or behind, should explain concepts multiple ways if needed, and should always include working code examples rather than abstract descriptions. A well-written system prompt like this does a surprising amount of work before you write a single training example. Creating single-turn examples. The fundamental unit of a chat dataset is the messages array. Each entry has 2 fields, a role and content. The role is always one of 3 values: system, user, or assistant. The system message appears once at the top and sets the behavioral context. The user message is the input, a question, a request, a problem. The assistant message is the response your model should learn to produce. This 3-part structure is the building block everything else is composed from. Here's a concrete single-turn example for the tech support assistant. The user reports their Windows computer is running slow. The assistant's response is numbered, actionable, and specific. Check startup programs, run disk cleanup, scan for malware, check available disk space, restart. Each step explains what it does and why it helps. The response closes by inviting the user to follow up. That closing line matters. It models the behavior of a support conversation that doesn't just drop the user after answering. Here's the creative writing coach version of a single-turn example. The user asks for help with a mystery story plot. Rather than delivering one answer, the assistant offers several distinct directions: a locked room mystery, a cold case, an unreliable narrator, and then asks the user which angle resonates. This is deliberate. The assistant isn't solving the problem, it's opening possibilities. That collaborative dynamic needs to show up consistently across every creative writing example in your dataset. Creating multi-turn examples. Multi-turn examples are where fine-tuning gets genuinely powerful. Instead of a single question and answer, you're showing the model how to maintain context across an entire conversation, how to remember what was said 2 turns ago, how to build on partial information, how to ask clarifying questions before jumping to solutions. The messages array works exactly the same way. You simply add more user and assistant pairs after the system message in alternating order. Here's a multi-turn tech support example for a Wi-Fi connectivity problem. The conversation doesn't start with a solution. It starts with the assistant asking what the user sees on the Wi-Fi icon. The user responds, and only then does the assistant suggest forgetting the network and reconnecting. The user hits a new issue with the password, and the assistant adapts. This back and forth is exactly what you want the model to learn. Gather information first, solve incrementally, and confirm at each step rather than dumping every possible solution at once. Generating synthetic data. Here's a technique that can dramatically accelerate your dataset creation. Use the base model itself to generate training data, then manually edit the outputs to match your target style. You're not blindly accepting what the model produces. You're using it as a first draft generator and applying your own judgment to every example before it enters the dataset. This script loads a base llama model with unslots, using 4-bit quantization to keep memory usage manageable. The generate_conversation function takes a system prompt and a user message, formats them into the chat template, tokenizes the input, runs inference, and returns the decoded response with special tokens stripped out. Below that, a list of Python tutor questions feeds into a loop that calls generate_conversation for each one and stores the result as a properly structured messages object. The final dataset gets written to a JSON-L file. When it runs, the output tells you exactly how many examples were generated. That number is your starting inventory before the manual review pass. The critical step after generation. Read every single output and edit it to match your desired style. The base model doesn't know your target personality yet. That's what you're training. Treat the generated responses as raw material, not finished product. Template-based generation is a faster path for structured domains. The pattern is simple. Define a conversation template with placeholder slots for the problem and solution, then create a list of problem-solution pairs representing the scenarios your model needs to handle. The code iterates through the pairs, fills in the template for each one, and appends the result to your training list. For tech support, you might have 20 or 30 common issues. This approach turns that list into 20 or 30 training examples in seconds, all with consistent structure and tone. The third generation strategy uses GPT-4 or Claude as a data factory. Write 3 to 5 examples manually. These are your seeds, and their quality sets the ceiling for everything generated from them. Send those seeds to GPT-4 with a prompt asking for 50 similar variations. Review and filter what comes back. The prompt to use is shown here. This prompt gives GPT-4 3 seed examples and asks it to generate 50 more conversations in the same format. Same system prompt, same structure, tech support questions with step-by-step solutions, output as JSON with a messages array. The reason you specify the output format explicitly is that JSON with a consistent messages structure drops directly into your training pipeline without reformatting. After running this, you'll get a batch of candidate examples. Expect to discard or rewrite roughly 20 to 30% of them. That's normal and worth it for the speed gain. Data quality validation. This validation function reads your JSON-L file line by line and runs a series of checks on each example. It verifies that a messages field exists, that there are at least 2 messages in the array, that all roles are valid values from the allowed set, that roles alternate correctly after any system message, and that no message has empty content. It also flags assistant responses that are suspiciously short, under 10 characters, or unreasonably long, over 2,000 characters. At the end, it prints either a clean bill of health or a summary of every issue found, including the first 20 specific problems. Run this before every training run. Catching a malformed example here takes seconds. Catching it after a failed training run costs hours. Automated validation catches structural problems, but it can't catch quality problems. For that, you need to manually read a sample of 10 to 20 examples from your dataset and work through this checklist. The format section confirms your structural basics. Messages have the right roles, they alternate correctly, and the system prompt is present and consistent across examples. The content quality section is where human judgment is irreplaceable. You're asking whether the responses are actually helpful and accurate, whether the tone matches your target personality, and whether the answers feel natural rather than robotic. Diversity checks confirm you have a range of question types and difficulty levels, not just easy softballs. And the safety section is non-negotiable. Verify that no example contains harmful content, that sensitive topics are handled appropriately, and that the model isn't being trained to say things you'd be uncomfortable seeing in production. Complete dataset creation script. This script ties everything together into a single runnable pipeline. It starts by importing dependencies and defining the system prompt for a Python programming tutor. It creates the output directory with exist_ok equals sign true, so it won't fail if the directory already exists. Then it builds training examples of structured messages arrays, each one a complete question and answer pair with code snippets where appropriate. Validation examples follow the same structure but are kept separate from training data. Both sets get written to JSON-L files. The terminal output tells you how many examples were saved to each file and where they live on disk. After saving, the validate_chat_data function runs automatically on both files, so you get an immediate quality report without a separate step. Dataset organization. The standard split for fine-tuning datasets is 80 to 90% training data and 10 to 20% validation data. For a 300 example dataset, that means roughly 250 examples for training and 50 for validation. The validation set is what you'll use to monitor whether training is actually improving the model or whether it's starting to overfit. Keep these two sets completely separate and never let validation examples leak into training. The recommended directory structure puts everything under a datasets folder with fail names that encode both the use case and the split. For example, chat_tech_support_train.jsonl and chat_tech_support_val.jsonl. This naming convention pays off when you're managing multiple fine-tuning experiments simultaneously. Your training script will reference these exact paths, so a typo in the fail name means the script fails immediately. Get the names right once and they'll work consistently across every run. Lesson checklist. Before moving to training, run through this checklist. Planning. You've defined the assistant's purpose, written a system prompt, and locked in a personality and tone. Data creation. You have a mix of single-turn and multi-turn examples. You've hit the 200 to 300 example target, and you've split the data 80/20ths into training and validation sets. Quality. Automated validation has passed with no structural errors, and you've manually reviewed at least 10 examples for content quality, tone consistency, and scenario diversity. Files. Both JSON-L files are saved with proper JSON encoding, correctly named, and in the right directory. Check all of these before proceeding. A clean dataset here means a smooth training run next. Key takeaways. Right here, Eka. 6 things to carry forward from this lesson. Quality beats quantity. 200 great examples will outperform 1000 mediocre ones. The system prompt is your primary control over model personality and behavior. Multi-turn examples are what teach the model to maintain context across a conversation. Validation is not optional. Run both automated checks and manual review before every training run. Start small. Test the model. Identify gaps. Improve the dataset and repeat. And consistency matters above all. The same tone, the same style, the same constraints applied uniformly across every single example. What's next? Your dataset is built and validated. The next lesson puts it to work. Continue to lesson 5.3, Fine-Tuning for Personality, where you'll take this dataset and use it to actually shape how your model thinks, responds, and sounds. Additional resources. 3 resources worth bookmarking as you build out more complex datasets. The OpenAI Data Preparation Guide for format best practices, the Alpaca dataset as a reference for instruction following structure, and the Shared GPT dataset for real-world multi-turn conversation examples. Study these not just for format, but for what high-quality examples actually look like at scale. 2 dataset formats dominate the fine-tuning ecosystem, and you'll encounter both of them. The Shared GPT format uses a conversations array where each message has a from field, values like human and GPT, and a value field containing the text. The OpenAI messages format uses a messages array where each entry has a role, system, user, or a, and a content field. Unsloth works natively with the OpenAI messages format, which is what we've been building throughout this lesson. If you find an existing dataset in Shared GPT format that you want to use, it's a straightforward conversion. Map human to user and GPT to ASIN, but knowing the difference up front saves you from a confusing error message later. Here's how a multi-turn conversation maps onto the actual token sequence the model sees during training. At the top is the system prompt, role, rules, context, which appears once. Then user turn 1 feeds in, followed by assistant turn 1. If the conversation continues, user turn 2 follows, then assistant turn 2, and so on. The entire thing gets flattened into a single tokenized sequence before it reaches the model. This matters because the model doesn't see a structured conversation object during training. It sees one long stream of tokens with role markers embedded in it. Understanding this helps explain why consistent formatting across your entire dataset is so important. Any inconsistency in how roles are marked becomes noise in that token stream. Here's a quick sense of scale for the public datasets you might draw from or compare against. UltraChat sits at 1.5 million entries. It's a research-grade dataset and not something you'd replicate manually. Open Assistant has 161,000 entries, Shared GPT around 90,000, and Alpaca with GPT-4 annotations around 52,000. Dolly 15K has 15,000 entries, and at the small end you have custom labeled datasets in the range of. The key insight from this chart isn't that bigger is always better, it's that even 1,000 carefully curated domain-specific examples can produce a model that outperforms one trained on 50,000 generic ones, because relevance to your target task matters far more than raw volume. This pipeline shows what dataset preparation looks like at production scale, and understanding it helps you apply the same thinking even to a small dataset. You start with 500,000 raw conversations. Deduplication removes near identical entries, bringing you to around 450,000. A language filter narrows to your target language, landing at roughly 430,000. A length filter removes examples that are too short to be meaningful or too long to train on efficiently, cutting to about 380,000. A quality scoring step, typically using a classifier or heuristics, filters down to 200,000. A safety filter handles the final cut, arriving at approximately 195,000 high quality. Even if your dataset is 300 examples rather than 500,000, the same pipeline applies. Deduplicate, filter for language and length, score for quality, and check for safety. The steps don't change, just the scale. This quality rubric gives you a structured way to evaluate any training example, generated or handwritten. Relevance. Does the assistant's response actually address what the user asked, or does it drift? Accuracy. Are the facts and code examples correct? One wrong answer in your training data teaches the model to be wrong. Completeness. Does the response cover what's needed without padding it with filler? Coherence. Does the conversation flow logically from turn to turn, or do responses feel disconnected from what came before? Tone. Does the response match the personality defined in the system prompt throughout, not just in the opening line? And safety. Would you be comfortable if this response appeared in a live product? Apply this rubric during your manual review pass, and you'll catch the issues that automated validation misses entirely. This chart shows a category balance problem that's easy to stumble into without noticing. The brown bars represent the actual distribution across categories. General Q&A dominates, while creative and task execution are severely underrepresented. The green bars show what a balanced distribution would look like. An imbalanced dataset like this produces a model that handles general quanda confidently but struggles with everything else because it simply hasn't seen enough examples of those other categories to learn them. Before finalizing your dataset, count your examples by category or task type. If one category has 5 times the representation of another, either generate more examples for the thin categories or downsample the dominant one. Balance in the dataset produces balance in the model's capabilities. These two histograms show the token length distributions for user turns and assistant turns in a well-constructed dataset. User turns cluster tightly. Most fall between 30 and 50 tokens, reflecting how real users actually write concise questions and requests. Assistant turns spread much wider, peaking around 100 tokens but extending out to 500 because good responses often require explanation, context, and what this tells you practically. If your assistant responses are consistently under 50 tokens, they're probably tutors to be useful training signal. If they're consistently over 400 tokens, they may be padding. Aim for assistant responses in the 80 to 200 token range for most conversational tasks, with longer responses reserved for examples that genuinely require depth, like debugging a complex piece of code or explaining a multi-step concept.